Right, so straight on from the other air cooler that we fixed. So this one is a 2 litre John Lewis SW1V2QQ air cooler, 45 watts, 240 volts. Got meter and ohms. So let's quickly just test my leads. We're pulling up 1 ohm. I could rail them if I wanted to. So earth to neutral and earth to live, clear, and then live to neutral, 1.4 mega ohms. I'll be happy to plug this in. Basically looking for shorts or high resistance or something like that. So this thing is massive, 42-inch tall. So in the dim bulb tester, both breakers are off, so this is going to go through a 70 watt lamp. We may see a flash, all depends on the caps, I don't know. Let's see what happens. I heard it beep on, so I'm at the end of it here. I heard the pump go, and it's like, oh, okay, so the pump's actually got a float onto it, so that'd be a sensor. So if we held this upwards, try to turn it on again, it'll think it's got water in it. Yeah, there's no fan. Can hear the pump trying to pump there. Let's go with 1 amp. Quite happy with that. Can you hear the pump? If I hold on there, you hear it vibrating maybe. We have no fan speed, no fan whatsoever. So the pump's working, which is one good thing. So let's unplug this and just take it apart. So first of all, assume this filter comes out. So what I'm going to do is get it apart so I can actually look it on the bench rather than bits of it. So assume where it's got a tag. Okay. Oh, a few dead bugs, but nothing crazy. We can clean that out. That's almost safe. Right, let me get this apart and bring you back in, because you can't really see much apart from me taking some screws out. So I'll let the camera run and I'll speed through and put some. Right, so we are free. So I'll pop that one back in there. Lay this flat somewhere. Right, so we've got a pump down here. We have a motor in there, which we'll have to get to. And we got the brains up the top with a cap. So I think if I spin this round, let's have a look at the business end, as it were. Right, so you can just make out the motor there. Bearings sound good in there. We've obviously got an oscillator motor here, similar to the Black & Decker one that I've done. Some nice plugs. There's our starter cap there, which we can test. It's got 4 wires going to that one. And so if we trace our motor, so we have mains coming in, which goes to this plug here. So that's mains in. A motor. This is our pump. Right, that's the pump one. There's our motor. Up here somewhere. Somewhere it's hiding. Ooh, looks like a thermal switch there, maybe. Where's the motor wires? Oh no, we've got another starter cap down here. Slide this in. So that caps are something else. Then we get these screws off. So yeah, that's the starter cap. We do have a joiner here in some heat, looks like fireproof protection onto it. So the motor, it does come up onto this one. Right, so we've got the motor connections here. So let's do the same as the B&Q one that we fixed. We're going to measure all three coils and see if it's balanced. So make sure the coils are okay. So if we go red to orange, so to me that's 3 and 2, we have 2 to 4. Okay, so if we go 2 to 1, which is orange and grey in this case, 2 to 1, and 156, 156, 156, 224. Obviously 224 should be 380. 381, 381. So red to grey, 381, bang on, yes. And let's see if we get induction through this, which we do. Okay, so we know the actual 3 coils are right, so let's go neutral. There's 1 meter turning itself off. Let's just reset that. Right, we're in mega ohms there. .53 meg, 52 and falling. Something's wrong with that neutral. Orange, 54 meg, 54 meg, all to neutral. Something's wrong with the neutral. You can't have all the same readings. There should be 3 separate readings. So if we go to the case of it, no, nothing's shorted to earth, to the casing, sorry. Now, because we plugged it in, we could still have charge on that cap, which is down here, down the bottom. Let's see if our neutral goes to the plug, which should be this pin here. We have 1.4 meg coming in from this plug. So, excuse me, hit my head. So, yeah, neutral comes in here and goes to here. 1.4 meg. Let's unplug this motor in case we're reading the board. Right, now we should purely be on the motor. Let's see what we get from neutral to each coil. So if I go into here, then go to the back of the neutral, we should have a dead short, which we do. So we know we can go at the fronts now. So red, yeah, no reading. Orange, nothing. And grey, nothing. Let's just double check it on. Correct. I can see the clink there. No, there's no reading from neutral. There's something wrong with the neutral. So I'm going to guess there's a thermal fuse in here. Right, so instead of having to strip this down completely, because the starting cap's under there, it means you've got to take the whole body out. Basically, we've undone a screw here. There was 4 screws holding the motor in place, and that literally just slid out. So I've moved it on the bench. We seem to have 4 bolts. We should be able to take this rear off, and I'm hoping to see a fuse in there. or at least we can meter out where the neutral goes. Comes. There we go. So we've got a washer in there. Bearing's still on the shaft. So we're looking to follow that blue, which I think is that there. Get the grommet off. Go back on there from there. Keep it safe. Yeah, I can see the blue goes straight into that there. I'm going to zoom in a bit, give you more of an idea. You see it there? I think that is the thermal fuse. Why it overheated, I don't know. I'm not sure if it is repairable. Let me unplug it completely. I'll zoom you back out, and we'll gently try to expose that blue connector. Right, we're starting to expose wires there. Aha, is that one? There it is. That's exactly what I was looking for. Sorry, let me zoom you in. Can't see anything up there. There it is there. So if I pull out this old one from an old motor, that's exactly what I was looking for. That there. I'm not sure if that's a burn mark at the top of that one. Just got to be so careful with these wires. I know they're laminated or lacquered. Just don't want to break any. Get me caught and pull them. Okay. Yeah, we're going to have to undo this so we can slide that sleeving right down, get to a terminal, which should be a crimp joint on these. There's the thermal fuses. So I'll squeeze it so it goes around. Or circular, as it were. Right, so here we are. So if I go on to resistance mode or diode mode or continuity, any mode really, we can test that we don't have a break. Again between the neutrals, so we have our plug leads. So we're neutral on the plug and neutral here, and we have continuity down to the motor. So what we need to do now is slide off that grey side and just watch, because we do have a second wire coming out of there. So we'll break it. I can say this would be fantastic. I'm not fussed if I have to buy a new motor, but if anything I would like to see why it was failed if I can't safely repair this. So we're in resistance mode and the leads are at 0.8, 0.2. So it's the camera. Right, so if we go across one side, obviously I don't want to touch my fingers because I'll get the resistance of my body, so we just touch the other side, make open circuit, so 100% that thermal fuse is gone. So be so careful with this tiny little wire here, you can't see it in the camera. See if I can actually see what that is. So there's no way I can get the microscope on top of this. Aha. It is a RH130, 180 degrees Celsius, 250 volts, X43. So RH130. Let's clean that off just a little bit. This actually comes in quite. I had these for locksmithing, and I see Mick on Bite Fix It use one, and I thought it's a great idea. Let's out again. I mean, you can, but if we go red to this side of the coil, we have 579. And if we go to orange, which will be less, so more 806, because that's 0.80 kilo ohms. So that's 806 ohms, 806, and then this one's going to be higher, probably about 880, 900, 960. Okay, and we could do the trick of adding them three numbers up and do power squared, divide by that, tells what the wattage of this motor is. 100% it's that fuse. I'll have to order one up and I'll bring you back in once I get one. Right, that's the motor back in. Let's go back on the lines and find my leads. It's so awkward working as well. It's big. So if we go to neutral this time, being the blue, and we go to grey, we have 972 ohms, so you're looking at 971 kilo ohms. So 971, 812, 600ish, 580. Perfect. No reason why this shouldn't work now. Shall I spoil it and just turn it on? Yeah. Right, there's no water into it, obviously, so I will have to lift up that pump because I don't think this will go unless it's got water in it and it recognises the flow. So just double check. Plugged in. I don't have the screws. The fan's free. Nothing else is unplugged. Right, so let's switch it on. You get a beep. Let's turn it on. Yes. Oh yes. Speed 1, so we get speed 2, just like the other one. We've got flicker there. What is that all about? Oh, that is 2, sorry. There's 3. Oh, let me go on to full. Woohoo! That is magic smoke. Oh dear. Oh dear, dear, dear. Right, so this is a bit more involved. A bit more involved than I thought. It seemed measured out fine. It obviously didn't like what I did. Okay, so oh, I really wasn't expecting that. I thought I'd take this apart again, and when I did turn it on, smoke wasn't coming from that, it's actually coming from this. I thought this was some form of joiner, and you know what, it's still quite warm. So I'm going to see what's inside this. It is unplugged, because the meter itself was metering out fine. Sorry, the motor was metering out fine. Oh, yes, right. I think we can obviously see something that was getting hot in here. I don't know what's in here, so it has been plugged in, so I'm going to just be really careful. Something's fused in there now. I'm going to have to cut this open, I think. Surely I would have thought this was just a joiner, because it's the cap's there. So I call it starter cap. Here we go. Right, so them connections there are burnt out. Let me zoom you in. So whether they got hot and started shorting together, because I didn't actually test this, because I thought it's exactly what this is. It's just a straight joiner. So let's just put. Oh, the motor might be right. Well, we'll see. Meter's actually on. Box DC. Sorry, I keep saying it, but there's not much room here. Just make sure there's nothing in this cap. No voltage. It's an AC cap. Yeah, there's nothing on there. I did actually unplug the motor and test the output in case he was putting 240 to 2 coils at the same time. That was fine. So 1, 2 and 3. This obviously pushes down and clips out. Okay. I mean, they're in there. Why has it got thermal insulation on it? So I can get to the terminals there. We've got no voltage. So capacitance probably like 1.5 microfarads. What we got? I did say 1.7 there for a second. 1.7 microfarads. I put the ESR meter on this as well. Obviously this needs to be cut off. Look. Anyway, regardless, let's grab a meter. So 0.1 to 0.3 sort of is okay. Sorry, you can't see this. Back into shot. 0.8. That's dead. So whether this is shorted, started heating the terminal, and that's what went on fire, and that's what the smoke, and that makes a lot of sense because the bulb itself was flickering. Okay, might not need a new motor. Right, let me get this cap out. I do have some spares. I actually bought two a while ago. So yeah, let me unscrew this. I might be able to clip that out and get a new one in there. Right, 1 microfarad. Ooh, I've only got 1.5, I think. 1 second. Yeah, I knew I had one here. 1.5. Can I swap these? 1 for 1.5. I'm going to have to look this up. But short answer is no, I can't swap a 1.5. Swap a 1 for a 1.5 because it produces 50% more, it's more torque, overheat. So I looked at the second one I bought, because I bought 2 1.5s. That's a 1.2. So yes, on a 45, a small 45 watt motor, I'll be able to fit this one. It's fine. It'll probably pull more current, say 20% more, wasn't it? 1.2, yeah, 20%. And technically, it should just pull more current. I mean, I can order one. But, I want to try this. So let me get this soldered in. We've got free spider. Hello, mate. I'm going to put him outside. Right, he's free to do whatever he wants. Subscribe to this. I'll do a bit more research saying about the over, but I mean they don't cost much, the caps, and it won't take much to swap it. So I'm quite happy to buy a microfarad. I might just buy a little kit of them. Absolutely fine. So the same as we did on the other fan. I'm just going to use some heat shrink, insert these cables. I mean, it was in this joiner anyway, so should we just put it back on? Let's have that clipped in. Yeah, that should go back on. Can't see it doing much. I mean, what's he going to insulate? But anyway, stop any heat going to that plastic connector before, maybe. Right, sorry about that. Now we can sort of see. Whereas before it seemed to be bright on one and it seemed to get dimmer. So obviously it's supposed to be dull, medium and then bright 1, 2 and 3. So I'll put this on 1, which is that one. So we're pulling 30, sorry, it's dropping down, 21 watts, 20 watts. Stable at 21.8, I'm not sure if you can see that there. 20.29. Let's go up to 2. Now we're still just on lamp only, so speed 2. Pulling 23 watts. And no magic smoke. Now we're pulling 27.3 watts, and then if we cycle, let's watch the bulb. Low, medium, high, perfect. So let me turn that off. I'm going to allow it to stop. I'm actually going to turn on the 1 amp breaker, and this is 45 watts. So let's turn she on. It's automatically started at 3, so where it's got memory. There's 1, pulling 22 watts. There's speed 2, pulling 28.4 watts. And speed 3, pulling 40.54. So yeah, remember I said it was I thought it was 40 watt motor. This is saying 45 watts, so maybe they're classing 5 watts as the electronics. But it's pulling. Oh, the pump. Sorry. So let's turn the cooler on. Because it won't detect the water there. Right, and of course it's got the oscillator as well. So that's working, and then the oscillator, which is so awkward to film. You see it moving there? That's it in there. And what we would see is the fins moving at the front. Obviously I can't pick this up. Let me turn it off just in case. But be careful what I touch. So let's see if I can turn it on without trapping my fingers. And turn the oscillator on, which are on there. So yeah, you can see the fins moving, and there we go, trapping fingers like I predicted. And as you move back, you can see that. Perfect. I think I've spoilt it again. Will it work? I think we know the answer. Let me get this back together. My son will be well happy. Well, this is a bit deja vu for me, because literally this time yesterday I fixed that Black & Decker one. We didn't come remote control this one, so I thought I'd try the Black & Decker, but it doesn't actually work. So let's switch this on. So I'll have to look in for a remote control for this. So let's go on. You can definitely hear that. That's on speed 1, 2 and 3, pulling 43 watts. Okay, let's try the oscillator, which would be these fins. There we go, you can see them working. So let me spin back. Lovely, and we put the cooler on. I have got water in this, you can't see it, it's at the bottom there. Yeah, we're up to sort of, I don't know, a third. Oh, I can hear it gurgling. So if I was to turn this off, we might hear the air in it. Have you heard that? So yeah, it's fully working. Well, another one saved from landfill. This one was starter capacitor. I call them starter capacitors, but CBB 61S. It's a 1 microfarad capacitor. Yeah. Well, thanks for watching. My son will be delighted, and I'll do some more videos soon. Thank you.